giving me wind and rain. You're some kind of butterfly.
Hey there and welcome. Today's video is brought by a new collaborator with the channel. I'm talking about Zoyi. They sent me for review their brand new 2-in-1 oscilloscope plus multimeter. I already took a peek. Seems very well built, but that's all I did, and I left the testing to do with you. So as usual, let me thank Zoyi for sending this device free of charge for this review. I didn't receive any payment from Zoyi for making this video, and I would like to thank you, my viewer, that have been supporting the channel by using the Access affiliate links in the screen or the product links in the description when doing your purchases on AliExpress or Amazon. You pay the same, but give a big help to maintain this channel by using these links. Okay, no more chit chat, it's review time. Let's start with the feature highlights. So let's start by seeing the box and how it is delivered. It comes in this retail box, no special informations or brands on it, so let's open and see what we have in here. Okay, so it seems that we have a bag. This is a nylon bag. I don't know if it is waterproofed, but yeah. Okay, so inside we have several bunch of stickers, the DMM.com, okay, a user manual, small letters but with color, yeah, infographics, so seems to be okay, all the menus. We have several languages or not? Nope, this is only English. All these pages are in English. Okay. We have here, let me open to see what we have. Well, it's kind of stuck. Okay. We have, yeah, test lids, those that we can screw and change the ends. Whoa. Yeah. You got the idea. We can, this is a multifunction cables that we can put several ends in here, and we have a few of them. Let's see what we have. We have alligator clips, we have this pointing one, and yeah, it's the crab claw. I think it's open and he lost several of them. Yeah, let me take it out. We have here a few more. Yeah, let's take this out. The usual cable, USB type A to type C. Some more stickers from Zoyi. Okay, it seems to be stickers, I don't know. And we have also this. Yeah, this is to connect directly in the inputs. So we have a multifunction cables. The cable quality, let me see, it seems to be very flexible. I am not sure if it is silicone. I don't think so, but it is really very flexible. As you can see, it is not very thin or very thick, but it is very flexible. Seems to be nice. Okay, and as always, a pair of lids also. And we have these test lids. I believe this even will enter on a protoboard. Let's see. Yeah, very sharp. and it will even be able to use it on a proto board. So yeah, very nice. Also the cable also plastic but very flexible, also nice quality. And that's it. Let me take this out of the way. Also delivered with this is this probe 60 megahertz. It's the P2060, I believe. And yeah, for the oscilloscope. So pretty nice. Okay, so in terms of construction, as I told you before, it seems pretty good. We have this plastic, hard plastic part, and this one is like rubber. Yeah, it's anti-slip rubber or something like that. On the top you have the connection for the channel 1. It's a Cat2 connector. So yeah, in terms of rest, you have this holder that allow you to have in a very nice and comfortable position the device. On the right you have here the connection for charging and connect to the PC, and also the output for calibration, and I believe, yeah, signal generator, I think so. Yeah, we will see. And yeah, we have here the sticker to prevent connecting the wires in the wrong place. So the normal connection with volts, ohms, hertz, and I even see here the temperature. So this will be able to read temperature. Okay, the buttons are rubber. Very nice to press. Yeah, easy to press. You can feel the click while pressing it. And yeah, that's it. Pretty simple. This is a rechargeable device, so no batteries are required. Okay, let's power this on and start to see the operation of the device. So let's start by describing what we have here. We have 4 keys, 4 function keys. I think it's better to power this on. Yeah, it will show you better. So we have 4 function keys that are aligned or are correlated with these options in the screen. It's easy to change every option, quite intuitive. Just press the key. And we have also obviously the on and off button. While in oscilloscope mode you have the auto, and this key in multimeter mode it will be the range, manual or automatic. While in oscilloscope mode you have also the hold key. That hold key is in an oscilloscope identical to the stop key or the single key. If you want to stop the signal and analyze it. If you press it for a few seconds, it will allow you to save the waveform. And in multimeter mode, this will allow you to just freeze the value on the screen. Obviously, you have also the mode key that will allow you to change between modes. It's really easy to use. You have the extended menu key. You just press this key and another menu will appear. And the directions keys allow you to change the value of the amplitude and time division. Okay, so really easy to operate. Also, when in trigger mode, you can also change the position of the trigger. Let me see if I can do that, like this. And as you can see, it updates here the trigger position. So let's start now talking a bit about what you see in the screen. I begin with this. You have also the battery indicator. This is the trigger position in the screen. You have the amplitude, the time division, and the memory depth with the position in the memory depth. Here is the trigger status. Right now it's running. You have the old, single, normal, auto, and TD when it's triggered. Also in the screen you have the frequency, the VPP, and the Vmax. This is fixed values. And you have here a few menus. Okay, so let me zoom in and show you the rest of the menus. Okay, so let's see what we have here. By pressing F1, you have access to the voltage time division control, as I've shown you before. You can also have access for moving the memory, the position in the memory depth buffer with this option. As you can see on the top, this little arrow is moving in the memory and also moving this in the memory. So let's put it again at 0. And you have also the trigger mode. With the trigger mode activated with the direction keys, let me show you. You can move the trigger position in the screen. And let's see the AC and DC coupling. Okay, pretty easy to change. So pressing menu like this, you have a new extended menu that you can use. You have the coupling also. You can change the trigger modes for normal, single, and auto. Also the trigger edge, rising or falling, and the probe attenuation 1 or 10 times. Using the keys, the left and right keys, in this case the right key, you can have another set of options like the language, the auto shutdown time. I think the maximum is 2 hours, 120 minutes, yeah. And also you have a few options for backlight, 100%, 30%, 50, 80, and you are not allowed to change this. You have only 4 options in terms of backlight. You can activate more measures, also fixed. You are not able to choose, you have those. And if you press again to the right, you have another set of options. The calibration menu, factory reset, the storage access, so you can access the USB from the PC, and it will show you the version in this one. This one, it does nothing. It's just for showing here the version. In terms of the storage, when you connect the cable to the PC, you are able to press this button. It will start the USB disk driver and give you the chance of removing the waveforms and put here files for update and stuff like that. Okay, in terms of operation, that's it in oscilloscope modes. Now let's move to multimeter mode. It's easy, just press mode. In multimeter, you have also a few options. You can use the voltage DC, AC. As you can see, you have DC, AC through RMS. You have also resistance, continuity, diode measurement, and capacitance, and that's it basically. Then you have amperage measurements, and I will press the F3, and if you notice on the screen when I press the F3, it will show you which sockets you should use to connect your leads, like this. Okay, it's a bit fast, but it's just an indication. And also if I go to, again, you have amperage in AC or DC, and you have also microamps, and again the correct sockets for connecting the leads, and you can change AC or DC. So there is nothing much more that I can show you. The extended menu has only the basic operation options, language, automatic shutting down time, and the backlight. If you press right or left, it will not change anything, and the direction keys will not show you anything more than this. Okay, so no use for that in this mode. The screen has a very nice image. It's very clear, very well defined, and personally I like a lot of this gauge with also the digital value in the screen. So yeah, That's it in terms of operation. Let's move on to the rest. So the first test that I will do is the waveform display and bandwidth. I have here my function generator already prepared. I will set up the amplitude of the signal to 1 volt VPP, and let's start with 100 kilohertz sine wave like this to see what we have here. Okay, we'll do auto. It takes a while to do the auto, but let's see. Yeah, it works fairly good. Just a quick note, I'm using this small bag from Miniware just to give the right inclination to the device so you can see better the screen without the reflection of the light. Okay, it seems fairly good for 100 kilohertz. Let's pass this to 1 megahertz. Okay, we will need to do an auto again. Still doing it. And yes, still nice, the sine wave, the draw. It seems that the sampling rate handles quite well the sine wave. One important thing, it's the VPP. It's 940 millivolts. So for 1 volt VPP on the function generator, we have 0.940 millivolts. That's good. It's over 714 to 20. That's the minus 3 dB. So it seems to be okay for now. Okay, let's pass this to 5 megahertz. And in 5 megahertz, we have still a very nice waveform. We are at the maximum of 100 nanoseconds and 200 millivolts in terms of amplitude. The sine wave, it's still good. Also, the VPP is over 740 to 20, still good also. So at half of the bandwidth of this device, we are good. Let's take this to 10 megahertz, the maximum. Okay, in the maximum you can see that the waveform is very jittery, jumping a lot. But one interesting fact is that the VPP is still over 714 to 720 millivolts, and that's quite good. Not so good, it's the waveform display. Everybody knows that you cannot, or you should not, analyze a waveform to the maximum of an oscilloscope. Just see what will be comfortable in terms of signal. And I think that 7 to 8 megahertz. Let me put this at 8. 8 still is readable. 9 is a lot of jitter, and yeah, 7, it's the magic number. I believe that 7, it's the waveform that's still usable, and you can read it on the screen. Even if the VPP it's over the 714. And this is normally the problem with these devices, because you have a stable waveform, but the VPP, it's not good. So I believe this has the 10 megahertz bandwidth maximum, but the waveform displayed, it's really, yeah, not the desirable one. Okay, in terms of bandwidth testing, that's it. Let's see in terms of waveforms. Let's start like 500 kilohertz again. Okay, let's try a square wave. Okay, we are getting some of these outliers. Yeah, this pointy out of the square wave. Let's see what will be a good square wave. 100 kilohertz. Oops, 100 kilohertz. Auto. Yeah, the auto takes a while to get there. Okay, let's increase this to be able, yeah, even 100 kilohertz, it's a little bit, yeah, it's not completely square. Let me try something to make sure that I'm being fair with, yeah, with the manufacturer. Let's take this to again and see if the sine wave, if the probe is properly compensated. We might have a small problem there. Yeah, and it isn't. So a quick fix. Let's put the probe correctly compensated. Again, I don't know what happened. And yeah, decrease a bit the signal. And it seems good. Yeah, seems quite good now. Okay, we corrected the issue. Let's see if the square wave now it's correct. Again, to my function generator, auto. Yeah, we still have these round corners. It's better, but we still have these round corners. That is not desirable at 100 kilohertz. So I think the problem with this is how the lines are drawn. Okay, let's see one more. We have the sawtooth and maybe noise. Okay, it's quite quick to update. Let's try just something to see. 100 kilohertz. I will now change the trigger modes to, wait, stop. And if you press again hold, as you can see, it captures again the signal. Yeah, it does a run. Okay, that's it for the oscilloscope. Let's move on to the multimeter. I have here the multimeter, my faithful power sock without security. It's much easier to test. So let's see how it handles AC voltage. Okay, so it's telling me that we have 240 volts. It passes a little. 49.99 hertz, and through RMS maximum 200.5.7. Again, I mentioned this also in another video. In my previous home, my apartment, normally it will go up to 234. So in this house I have a little more voltage. That's good. Okay, as you can see, the numbers became red to show you that this is little. 241 is oscillating. Okay, that's a winner also. Let's move on. I have my setup already in place, as you can see in the screen. What I will do now is just use my DC voltage calibrator from Time Electronics to test the values in terms of voltage and millivoltage from this multimeter. You have also on the screen my Siglent SDM3045X. It is a little better than this one. The Zoyi only has 9999 counts, But even so, you can check what values we have on the Siglent and on the Zoyi. Let's start. I will try to be fast with this. Let's start with 1 volt. 1 volt. So Siglent 9997 and Zoyi 999697. Moving to 2 volts. 1.9997 on Siglent, 2.00 on Zoyi. 3 volts. Okay. 4 volts. I think the values are really near. 5 volts. 6 volts. 7 volts. 8 volts and 9 volts, and we are done. Let's pass to millivolts range. 100 millivolts. Spot on, almost, yeah. 200. It's jumping a little, but it's there. 300. Okay, spot on, exactly the same. 400, 500, 600. Really good. It's 700, 800. And 900 millivolts. Going back to 0 and moving down again 1 decimal place. And let's start with 10 millivolts. 20, 30, 40, 50, 60, 70, 80, and finally 90 millivolts. I'm pretty happy with the resolution of this and with the accuracy. Let's go back to 1 millivolt. Spot on. 2, 3, 4 millivolts. 5, 6, 7, 8, 9, and going back to 0. We can try the lowest scale. It goes to microvolts. Okay, let's start with 1.1 millivolt. 0.2. Yeah, here is missing a little, but even so, I don't even know if this is within reach of the specifications. I have to see. 0.4, 0.5. Yeah, it's missing a bit, but I'm really happy with this. Don't forget, this is 9,999 counts. 80, 90, and back to 0. Okay, in terms of voltage, I'm pretty satisfied with this. So let's move on. So this is a classic here in the channel. As you know, when I'm testing a multimeter, I always go back to my millivolts reference board, voltage reference board. So let's first, before testing this, hear from our sponsor. Now is the time to talk about this video sponsor, PCBWay. I always use PCBWay for creating my boards with a professional factory quality, as you saw in my millivolt voltage reference board. It is very cheap to manufacture your PCBs on PCBWay. You can manufacture 10 PCBs for only $5. How awesome is this? And it is pretty easy also. Just insert here the PCB dimensions and you'll have an instant code. So When you want a PCB, visit PCBWay to get your code, and if it is your first time ordering from PCBWay, you can use our access link for a $5 credit. And don't forget, they also have component assembly service, 3D printing service, and much more. Okay, now that you know how to do a board like this, let's start to see what are the values that I get with using this millivolt voltage reference board. So the first one is 10.7. Okay, it's on the 10 millivolts pin. On the 25 millivolts pin, 25.2, very accurate. On the 50 millivolts, also spot on. 100 millivolts. Okay. This is not the best alligator clip, but it will do the job. 250 millivolts. It gives 256. I believe that the reference normally goes around 248 to 50. Okay. 500 millivolts. Let's see if I can grab it. 502. It's okay. It's the normal value. 1 millivolt should be below 1. Yeah. 989. And 2.5 millivolts. Also fine. And the last one is the 5 milli. Sorry, I was saying millivolts, but this is volts. 1 volt and 2.5 volts, the last ones. And the last, it's 5 volts. This one, not all the multimeters can read the 5 volts, maybe because of something wrong with this board. But I normally use the board precisely to see which ones are able to read the 5 volts in the board. And this is not one of those multimeters, even if it is an awesome multimeter in terms of display and accuracy, but on this it's not able to see the 5 volts. Not all of them are, as I told you before, but yeah, that's it. Let's move on. Now I am gonna test the resistance. I will use one of my reference boards. You have here the values. This side is resistance, this side is capacitance. Let's put this in, yeah, it's already in resistance. Okay, so let's start testing, and for the first value is 10 ohms. Okay, it's reading 12.56. Okay. The second value is 100.03 ohms. Okay, almost there. Very nice. Third value is 1.0003K. Really? Yes, spot on. Third value is 9.995K. Okay. It's jumping a bit, but yeah, acceptable. And the last value is 100.06K. Almost there. 100. Yeah, it's around 100K. Let's go back to the first one. I want to check again. 12.54. Yeah, it's a little off, but no worries. Okay, that's in terms of resistance. Let's move on. Okay, and now we have capacitance. Let's change this to capacitance. Okay, here you are. The first one is 102 picofarads, 0.117. It's a bit off, but okay, acceptable. The second one is 1.02 nanofarads. Almost there. The third value is 10.4 nanofarads. Almost there. With capacitors, it's always tricky to get the exact value, but okay. So next we have 98.7 nanofarads, and it gives you 100.2, a bit off. Next we have 929 nanofarads. This one, I don't know, I have to get another board because it's the second device that gives me this value, so I'm starting to believe this is the correct value. And the last is 10.0 nanofarads, sorry, microfarads. Okay, 10.6. Yeah, I think the difference should be in between the error margin of the device. So again, satisfied with the results. Okay, so now let's try continuity like this, and let's see if it is fast enough to beep. Okay, it takes about a second to update the screen. 1-2 seconds. Yeah, and is quite fast. It's quite fast to give the continuity signal. Okay, very nice. Also done. Okay, in terms of diode testing, I have here two LEDs to test. Let's see what we get. So I think you can see that the light turns on and it gives me 2.67. That should be all right for these LEDs. And for the red one, I also have the light on and 1.726. Also good. Wrap up time, and let me start with the price. I found it on Zoyi official store on AliExpress at 58 euros or around $62. And I must say, for this price, this is a really sweet device to have. You can buy it also on the Zoyi website, the dmm.com, at $69.99, but you will have a $5 discount on your first purchase, and using the TechCornerTV coupon code you will have an additional $4 discount, so it will be $16.99, even lower than AliExpress. It seems these oscilloscope plus multimeter are really a big thing these days. While it's not new, every brand is releasing some kind of device nowadays. Next video will be on a similar one from Zoyi, and I know that Fnirsi has something already prepared too. So, and I get it for a reasonable price. This is a nice tool to have on the field, working on repairing appliance or electrical repairs, whatever. It has good quality and a nice set of functions. While for me, that see in this bench a lot of devices to review, I think that maybe 10 MHz it's not much, but for the everyday professional working on repairs or even hobbyists, it probably will do the job for the most of the people. So in my way of seeing it, the cons are really the bandwidth and maybe some functions that some multimeters mostly have these days, like the NCV or one-wire detection or even the LED light. Those are not present. The waveform representation near the maximum seems also very jittery. But on the other hand, it does seem to have 10 MHz bandwidth, since the -3 dB voltage is above the minimum expected. But if you want the price to be competitive and still maintain the quality, something gotta give. And I must say that in the multimeter side, I was really satisfied with the accuracy of the readings. It was a win for most of it. In terms of finishing, the quality of the device is really good. You have this format that fits very well in your hand. The rubber finish prevents some slipping, and the rubber buttons are nice and respond well. The last thing that I should mention is the screen. It is very good and it has a very clear image. All things considered, it was really fun to do this review. It is always nice to verify when the specs are near the description that comes on the user manual. So for me, it's a win. If it is a win for you too and you are considering buying one, please don't forget to use the affiliate access links here on the screen before paying, or just use the product link in the description. You can become a channel sponsor just by using these links without any cost for you. Your help is really appreciated. And if this video was useful to you in any way, please help me spread the love and slap that like button. If you haven't subscribed yet, what are you waiting for? Go on! Almost every week I have something new for you. And that's all I have for you today. Thank you for watching until the end, and let's meet again in my next video.